Okay, here we go. All right. Showtime.
Showtime, yes, sir.
Okay. Okay. This is the chapter 10 lecture. So we're going to cover up to 10.1 and 2 today, and the rest of it we'll do on Wednesday. So here we go. I'm not showing anything I do.
There we go.
Okay, we need a light off because it's not going to really be. Is it okay if I put it? Is that all right?
That's good. That's good.
Okay. Yes, it is. You're up.
Is it real time?
This is real time.
But if I was
Showtime, baby.
This is real time. This is real time.
and it's
So what we're going to start is we're going to learn up the ideas of what are called hypothesis testing. And let's make sure. There we go. That's a little better. So this is the we're going to learn the ideas of hypothesis testing. So we're going to learn about the setup. We're going to learn what type 1 and type 2 error are. We're also going to learn how to state the conclusions of your hypothesis testing. And then what we're going to do is we're going to learn the classical approach in section 10.2 of your of the hypothesis test. It's actually the actual more of the mechanics or a little more of the guts of it. And that's as far as we'll go today. Okay?
Okay, sir.
Any questions on this? So this is called the setup for hypothesis testing. And in hypothesis testing, what we do, it's a procedure, or like a recipe, based on a sample of evidence and probability. And it's used to test statements regarding a characteristic of one or more populations. So, I think I might have to put up the screen a little bit, okay? So, if I'm going to write, I'm going to have to do this, okay? So, if you guys have trouble reading this, let me know. Well, let's bring it up and down. So, for example, does everybody know what a parameter is?
Yes.
Okay, the parameters that we're dealing, they're basically measurements associated with a population. Does that make sense?
Yes.
So parameters are measurements associated with population. So the two parameters that we're dealing with in this class are P, which is the population proportion, and mu, which is the what? Population mean. Good, thank you.
Can you repeat that, sir?
So the mean is the population proportion. Mean is the population. Excuse me. The mean, yes. Mu is the population. Mu is the population mean, and P is the population proportion. Thank you.
You got me screwed up already.
Okay.
I'm sorry. It's just.
That's going to be live. Everything you're saying is live. It's okay. That's all right. So mu. Okay, so we have mu. You're pretty funny.
I'm sorry.
It's okay. And P, this is the population mean. This is the population proportion. Okay. You gotta be careful because everything I'm not editing this. This is live. So everything you say goes live. That's all right. Your trip. Okay. And so those are the two things that we're considering. Is mu. This is the what? Mean. And mean, which is population mean, and P is the population what? Proportion. Yep. Those are the only parameters that we're going to be considering when we do hypothesis testing. You can do it with other types of parameters, but not with any others that we're going to deal with in this class. We don't have time to deal with other ones. Any questions on that? Okay. Oh, you don't have to do that, Martha. Thank you. You don't have to do that. Thank you. Thank you. Okay. Did everybody copy P and U? Okay, because then I'm going to put the screen down. You can see a little better. Now, the null hypothesis. So we have two hypotheses. One is called the null hypothesis. This is it's a statement it's one of the statements that we're going to test. And what it usually is, it's what you would expect. In other words, it's the hypothesis that you would expect to have. Okay? It's just something that would just have to happen, or not just has to happen, but expect to happen. For example, I really wish we have screens that I can stop moving up to a point. Let me try it. Just enough. Okay. So for example, usually the null hypothesis, which sometimes we call HO, which you can say that word, I will not say that live. You can say that word, now by the way, you're now immortal in this thing, is your null hypothesis, HO. And what it is, for example, let's say you're talking about the proportion of heads that occurs. So this is the proportion of heads that occurs when you flip the coin. Okay? So that would be what you would expect to happen. This would be the null hypothesis, which says that the proportion of heads that we expect to happen is equal to what? 0.5, which is what? Half. Or 50%. Okay? That's how we'd write the null hypothesis for this particular type of experiment. And another way to think about this is that the difference between the parameter P and its value is 0. In other words, there's no difference between the parameter we have here, P, and its value. Because if there's no difference, that means this value and this value are what? Equal. Does that make sense? If there's no difference between these two numbers, then this parameter and this parameter are what? Equal. The null hypothesis says that. The null hypothesis always has a equal sign, no matter what. Okay? Does that make sense to everybody? Does that mean yes? Does that mean no? You guys can talk.
Well,
I'm
just wondering if that P equals to half, is that including the parentheses information?
No, no. It's just this,
Okay.
and then this is just another way of writing that.
Okay, the difference between the P and the value equals to 0.
Yeah.
Or
Yeah.
0.
Yeah.
Can you show us an example? That's the example?
Yeah.
The flipping the coin.
Yeah. So flipping a coin. So this is an example of it. There's more. There's going to be more examples coming up. But this is one type. This is called your null hypothesis, and this is one example of it. And it says that the parameter P and its value are basically the same.
The parameter and P are basically the same.
The parameter P and its value, actually, let's be careful. The parameter P and its value are the same.
Is that word on the bottom flipping?
This is properties of heads that occurs when you're flipping a coin.
And the value is 50%, right?
0.5. You want to do a proportion. Yeah, you want to write this as a proportion.
Okay.
You don't really want to use these as percentages. Okay? Any questions on that?
And the value is a proportion.
Yes. So this is, sometimes we abbreviate, the symbol for this is P little 0. And P little 0 is the value of the parameter. In this case, P little 0 is what? 0.5. Do you see that? P little 0 is what? 0.5. Good. Good. Very good. Excellent. Any questions so far? You guys are finished. You're going to be live on YouTube.
You're serious?
I'm very serious. That's why I'm recording it. Hopefully, I don't know how great the quality is going to be, but hopefully it's doable. This might be a little too dark. Yeah, that's worse.
Just put turn on the back.
I'll figure that one day. Yeah.
And it's under YouTube, what?
Well, I'll tell you, or I might just put it up on my site. That might be better. Maybe I'll put it on my site. Okay? That way nobody can really see it,
Right.
besides you guys. So Martha, we won't broadcast your video anymore. Darn it, I was going to the nation. I was going to, but next time. Okay? Go ahead. So that's called the what hypothesis?
The null.
Null hypothesis. Now, that's one hypothesis. Notice nulls always have equal to's. Okay? There's an alternative hypothesis, is the other hypothesis. And basically, it's like opposite, or like alternative to the null. Does that make sense? So in other words, this is what we expect, and this is what we could also not expect. Or maybe this is what is more common, and this is alternative to what would be in common. Does that make sense?
Yes.
Rest of you all right on this? So what does that mean? Well, that means, so the alternative hypothesis, which we say is H1, that's how we abbreviate it, is a statement that we're trying to find evidence to support. So that's the claim, that's what, usually it's alternative to, or not usually, it is alternative to your null hypothesis. So for example, this is a little harder to write, but we'll do it. For example, that's what I don't like. You can't win. No, they don't want me to. So, as an example, let's do this. I guess that's all right. Here's your null. Again, this is the example of what? Flipping a
Coin.
and getting what? Heads. Now, we could have, one possibility we could have,
Is that 0.5?
Yes.
yep,
Okay.
one possibility we could have is that the actual portion of heads is greater than 0.5.
Oh, I see.
Okay? That's one possibility.
Can it be less than 4?
It could also be another possibility is that we could have, again, we have the null hypothesis, and the alternative is we could actually have less than 0.50 or 0.5. But there's okay, so it's either the first one, the second one, good, thank you, or there's one more. I guess I gotta write it above. Third one is not equal to. That means it's just not 0.5. Does that make sense? So it can either be greater than, it could be what? Less than, or it could be what? Not equal to. Does that make sense?
So HO is plus and HI is negative, it's null or not?
The null hypothesis is always that it's always going to be equal to the parameter's value. You're always going to have an equal sign here. You're going to have parameter equals a number here.
Okay.
Either a a decimal, or it's going to be a whole number. Because we can also have this with mu, with the population mean. Okay? The alternative could be, Martha, that it's either greater than, less than, or what? Not equal to.
So it will never be equal.
It has to find some, we know which is what.
Yes.
Okay.
And how you tell, I'm sorry,
It will never be equal.
No, because that's always got to be what? The null. The null takes the equal sign, always, no matter what. Okay? You can never have an equal to here, ever. That equal to is always taken care of in the what?
In the null.
In the null hypothesis, okay? That's really important. Yeah, Martha?
When you say no, that word, can't say it.
No.
What is that?
It's
That's,
zero.
that null is like another word for zero, yeah. Null means zero. So this is the zero hypothesis, if that makes it easier for you.
Yeah, it makes it much easier for me.
Okay, but just null. Let's have it. Try it. Null. Say there. You got it. That's easy. This one's too hard.
No.
You got it?
No.
Yeah? No. No. Is it no? You not got it? Is it
No, I
Okay.
like that one.
Okay. Okay. So, and then which alternative hypothesis you pick is basically it usually has something to do with the problem itself. In other words, there's certain words that you want to look for, which will determine whether you want to write what? Greater than, less than, or not equal to. Does that make sense?
Yes.
There's certain key words in the problem that will tell you that. Does that make sense?
Yes.
Okay. Any questions on this? Go ahead and copy this if you guys need to, and we'll go to the next slide in a minute.
Yeah, when it says that it's a statement, we are trying to find evidence to support what?
The null or the hypothesis. Those are these claims. Either this claim, that the parameter is the same thing, and the parameter's value is equal to, there are two different ways of expressing the same number. In other words, there's no difference between these two numbers, and there is a difference in this case. And there is a difference, in this case would be greater than, if we took the first one.
So it's trying to support either the null or the alternative.
Well, yeah, in essence, yes. And there's language that's really important here that we're going to go through, that we really need to go through. I mean, like critically important. And if you say it in a different way, it's actually flat out wrong. So I'm going to really stress it for you. So the language here is, I mean, in the whole class is key. It's super duper important. Okay? Really important. Can I change can I go put this down? Maybe if I go a little farther. Oh, that was dangerous. No, you're okay. You're fine. Thank you, though. I just didn't want to hit it again. Like last time. No. You're fine. No, that was my joke. That was klutzy. Okay, this might work. Yeah, no. Yeah, maybe. I'm thinking about, people. Let me. Yeah, maybe. I don't know if this is going to work. We'll see. No, you're fine. Here, I'll make it slanted.
No, you can't see her.
No, we can't see it.
No, we can't see her.
No, not at all. But you can't. How I do it? It's magic.
But you have to have the second face down.
Yeah, but.
Close it in. People are watching you?
No, you're not being. No. I don't think people are be able to see this.
Okay, that's good.
Yeah, but it's just, I'm just gonna. I guess I'll just. They have the slides.
It's a reflection.
So
But you
yeah,
can't-
it's
you can't
horrible
see it.
reflection.
Yeah, you want to turn it off?
Yeah, maybe.
Oh no, it's got nervous.
Of course. Let me try this one.
A little better.
Yeah, a little better.
Okay. Probably worse. What do you think? Is it okay? Yeah, be careful. I can go on it. Okay, you guys, actually, it looks like there's a reflection here. Yeah. Darn it. Yeah, so maybe, yeah, that's what I'm doing. Yeah, let's do that. Technical difficulties, everybody. Oh, I'm sorry. Is there a reflection there? I'm sorry.
It reduced the reflection, but it's still.
Maybe.
Let's turn off this camera.
Maybe. Yeah, let's try it.
No, it's,
It reflects out this way.
Yeah, I think, maybe moving it a little closer. I think we might have to move it closer. Here, let's do it together. Yeah, that's a good idea. How about here?
I don't even see the words. Oh, this is not good. Right there.
Okay, let's keep it there. Okay, everybody. So, those of you who are watching in TV land, this is our slide. Okay?
Hopefully,
And
it's
we'll see. Well, we're not going to publish this one. This is really bad. It's true. It's true. Well, they're going to take it as it is. I don't have time to edit this. Okay, here's an example. You guys showed up, so what's the deal? So we're going to learn how to set up the null and the alternative hypothesis. So in the past, student average incomes were what? Were $6,000 per year. Dollars important. That's important. An administrator believes that the average income has increased. So notice that you have what you would expect. The student average, which means mean, right, is 6,000. That's what you would expect. Okay, that's what we expect. But then we believe there's a claim on it, that there is an increase in the income. Does that make sense? Yeah. So increase has got to be what? Greater than, less than, or not equal to? Greater. Good. So here's how you would write your null and alternative hypothesis. I wish I had a clicker, but can't set it up with it. Come on. Oops, wrong one. Looking at the wrong computer. Okay, here we go. So do you see what the null hypothesis is? There's no change. In other words, the parameter's value, the parameter and its value are the same. Both what? 6,000.
When you mean both, 6,000, what do you?
The parameter is the actual measurement you're doing. That's mu. Okay? 6,000 is its value. That means there's no difference between, when you say a number is equal to some variable, like in this case, mu, the population mean, you're saying that this number and this number are the same.
So you just said the student average.
That's right. I did say the student average, but isn't that an average? Is the mean a type of average?
Yes.
Yes.
Okay. That's all I'm saying.
Okay. So the parameter is the actual mean, and the value is what you're actually measuring.
Right. So this says that this measurement and this measurement are the same. Or if you subtract 6,000 from both sides,
0.
you get 0. So let me see.
That's its value. I get it.
Okay. Can't wait. So let's see. See if this works. No, I don't show up here. I guess I have to.
Just leave it.
Just leave it up?
Yeah, leave it like right there. Cut it off.
I can't stop it though. That's the problem. It won't do it.
Right there is fine.
And there's nothing I can do about it. That's about as far as I can go. Okay? So look here, Martha. Okay? When you're saying this, you're saying the difference between this number and this number is 0. That's another way of thinking about it is the same value. Okay? That's what I'm saying. If you subtract 6,000 from each side, there's no difference.
Okay.
All right? Good. Now notice it's greater than. You guys agree? And when we have a greater than alternative hypothesis, we call this a right what? Tailed test. Good. So greater than means right. We're doing a right-tailed hypothesis test. Less than would be a left-tailed. Not equal to would be what is called a two-tailed. Okay.
Right two-tailed.
Because it could be smaller or it could be larger because it's not equal to. We just don't know which one.
So,
Yeah,
all right, no.
that's okay.
I was gonna say something, but.
Are you sure?
Yeah, because you say that if you subtract 6,000 from 6,000, it's no change, it's 0.
Right.
The high, the H1,
Uh-huh.
The mean is greater than 6,000,
Right, absolutely right.
meaning that the right tail would be tested. And
Well, that's called a right tail test.
so the mean is 6,000 also?
No,
No, okay, so that's what.
no, it isn't. What does it mean when you say that that this is greater than this? You're saying whatever number this is, it's bigger than this.
It just says, it doesn't give the actual right that we're gonna show it, but, I mean, will it show it on the test,
No,
like a number?
no. This is the number you put. You never put any number. This is what we call the hypothesized value. You never change this number. This number has to be the same as the one you have above.
And what about the mean?
What do you mean?
Was
What
the
about
number
it?
there?
No, you're just saying whatever it is, it's greater than that number.
Well, you don't know it.
That's right, you don't know it. You don't know it.
So it's like a guess, or?
It's not a guess, you just don't know it. You just don't know it. You're not guessing. You're saying whatever that number is, it's bigger than what? 6,000.
Okay,
No, you don't know it.
all right.
Okay? So that is a right tail test.
Okay.
Any questions on that? Now let's look at the other one. The percentage of passing a math course was 50%. So notice that you have a percentage now. So this is going to be P or mu? Which one?
P.
P, because you have a percentage. Good. So a math professor believes there is a what? A decrease in the passage rate. So your null hypothesis is always the parameter equals a number, whatever that would be. In this case, 50% or 0.5.
The
Yes, Martha.
percentage, when you said, would be 50%?
Yes.
Or it says the percentage of passing a math course is 50%?
Yes.
Is that it?
Yes. Sure is.
Where did you get 0.5? Do you back?
You change that to a decimal.
Oh, I see.
And the alternative would be that the p-value, the population proportion is what? Less than 0.5. Why? Because it's what? It's decreasing. Does that make sense?
Yes. And that's the left and the tail.
And that's a left-tailed test, that's right. Any questions on that? Okay, so, and just for completeness for you, you could have, if it had a not equal to here, it would be called a two-tailed test. So if we had not equal to, whether it's P or it's mu, you'd put not equal to. Does everybody know what I mean by not equal to?
Yes.
Okay.
Yes,
And that would be called a two-tailed test.
Two-tailed test?
Two-tailed test is correct.
So you write it as H1.
P not equal to 0.5 in this case. Yep, that's absolutely right. Very good. Thank you, Martha.
And that will be the both tails?
That would be both tails, so we call it a two-tailed test. Because this is left-tailed and right-tailed. And usually the word you want to look for when you have, so let me just put it up for completeness. So let's say you had, let's just do something else. Let's say it was the prices of shoes. So let's say this is the price of men's athletic shoes. We think the average price is what? 80. Let's say, well, no, that can't be a percent. That's a mean. So what does it have to be? Let's say dollars. So just in case, so if you're not clear, because if maybe it's not clear to you, it might not be clear to everybody else. So most likely that's probably true. This is your what? What hypothesis is this?
Your null?
Your null hypothesis.
Yeah.
Okay, good.
Your what?
Good.
Null.
Null hypothesis. Well, you both said it. Yeah. I thought you did.
No,
You just agreed.
I'm just agreeing with that.
So HO is the null hypothesis. Well, I guess I will toast it. It's HO. Okay?
Please.
Yes, I don't care. I don't care.
Can you say no, because honestly, I don't know what it means, but.
You should care what it means, actually. Yeah. You should care what it means. You really should, Martha. That's not really a good thing to do. You want to care what it means. Otherwise, I'd just teach you the abbreviation.
You know what you call the second one? Hi.
You can call it high too. If you want to call it that way, that's true. You can call it high. The alternative would be not equal to, let's say, $80. And this is two-tailed. A two-tailed test.
What are some of the keywords we found not equal to?
That could be one. One is differs or is different.
But would it also be increase or decrease?
That actually might happen, but I don't see that. I usually don't see that in problems too often. Usually differs or is different. Sometimes, not never, but usually different is kind of another way of saying increase or decrease.
Mr. Reyes, for the HO, the mean equals $80.
Yes.
And then the bottom one is, the mean is.
Not equal to?
Not equal to 80, which is the two-tail, just the HI is the two-tail.
H1.
H1?
Yeah. It's not an I. It's a 1.
Yeah, 1.
Yes. Yeah. Is that the question?
Yeah.
Yeah, that's what it is. Yeah.
So when we look at the two-tail and the keywords that we're looking for, this is differs from
Or is
null hypothesis or different?
or just different. Like test the hypothesis that the parameter, the average value of the price of shoes for men's athletic shoes is different than the hypothesized value, or is different.
Then the hypothesis.
Size value, or is just different.
Okay.
Any questions? Can I lower this, please? Is that okay? Well, I was happy to get half of you here. About half the class, a little less than half the class. I thought more people would come.
Did a lot of our class come? Yeah.
No, like maybe 30-40% of your class.
Did Griselda come?
Yes, she was here. Now, what I'm going to do, this is kind of there's errors that can occur when you reject the null, when you talk about the null hypothesis. So one key thing I want to tell all of you is that you can either reject, and I already know what I mean by that word, reject the null hypothesis, or you can not reject or do not reject the null hypothesis. Those are the key phrases I want you to know. So you either can reject the null hypothesis or not reject the null hypothesis. Does that make sense? So again, you can either reject the null hypothesis or not reject the null hypothesis.
Is that what they mean by type 1 and type 2?
It relates to it. It relates to it. And actually, now you can also create errors. A great example, and the type of errors that can occur when you do something that's basically, wrong, I guess, for lack of a better word or phrase, is you can create what is called a type 1 or a type 2 error. Okay? So type 1 error occurs when you reject the null hypothesis when in fact it's true. When you reject the null hypothesis, you reject it. That means you reject it. So for example, you reject that the proportion of heads is 50%. When in fact it's what?
50%?
When it really is 50%. Another way to think about this is to say that you're convicting innocent people. So let's say you're in trial and you have an innocent man or woman and you convict them. What does that mean? You find them guilty, but in actuality they're innocent. That would be a type 1 error. We call that a false positive. That's what's called a false positive. So convicting innocent men is a type 1 error.
So it's called a false positive.
Well, it's another name for it is called a false
I see
positive.
that in medicine a lot too.
Yes, you do. Yeah, somebody gets tested for PEDs, performance enhancing drugs, and they actually never took it. Or let's say, remember I talked about the poppy seeds, the poppy seed muffin? You get tested for tested for heroin. You've had a poppy seed muffin the next day. It shows up. You get tested positive for what? Heroin, but in actuality, you never took heroin because you had a poppy seed muffin. That could happen.
Where can you find those?
What, the poppy seed muffins?
I'm not saying I'm gonna go and get it, I just wanna know if they sell them here.
I don't know.
Do they sell them in like muffins and stuff?
Yes.
It's
Yeah.
because heroin is made out of poppies.
Yes.
That's why.
That's so. Yeah. So if you go to, you know what? If you want to take a little trip to Antelope Valley, there's a whole bunch of poppies there. You can go wild if you want to.
Really?
Yeah, of course.
beautiful,
It's beautiful. It'd be if you're consuming them,
I wanna
Martha.
know what they have.
Martha,
Yeah.
you might not want to do that. If you want to stay in, if you want to stay out of jail, you might want to kind of maybe avoid doing that. You have better things to do in your life. The other type of thing you can do is create or commit an error. The other type of error that we can have is called a type 2 error. This is like what's called a false negative. So this is not you actually don't reject that question. No, sorry. No, it's okay. This is you don't reject or you're not rejecting the null hypothesis when in fact the alternative is true. I don't really like how that's phrased, though when the H1 is true. I rather say when H0 is false. You see what I'm saying? H0 is false instead of H1 is being true. I mean, it amounts to kind of the same idea, but I like that. In most books I've ever seen, usually you usually say, so make this instead H0 is what? False instead of H1 is true. It amounts to the same thing, but just stylistically, I think it's better to talk about it that way. So this would be acquitting. Does everybody know what I mean by the word acquitting?
Yes, yes.
Acquit means to find not guilty. Okay? So you acquit someone when in fact they're guilty. That's a type 2 error.
Acquitting is what again?
It's to find not guilty.
Find that again.
Mm-hmm. Yeah.
So you said not rejecting the null when the
null hypothesis is false.
okay, no, that's what I came.
False negative, right?
Yeah, it is a false negative. So in other words,
So you want us to change H1 to...
here, I'll do it for you, Marty, just a second. I'll take care of it for you. So what I want you to do, I do that. I just do that. There's no happy medium here. So instead of writing when H1 is true, what I want you to write is when H0 is false. That's all you have to do. The rest of it's okay. Because usually what we do is either we reject or don't reject the null hypothesis. And we want to kind of get in the habit of just focusing on that. All right? Does that make sense? Okay. Any questions on this?
Well, never mind.
No, go ahead. Leave it out.
No, that's okay. You already gave some examples.
I'm going to get some more. We're going to actually talk about this. Not a lot. Most likely I'm not going to test you on this for your final. I'd say there's a 99% chance that I will not test you on this type of stuff on your final. That means there is a 1% chance that I could. But I'll be more precise later next week, okay? All this coming week.
Is that 0.01?
It is 0.01. It's not divided by pi. It's just 0.0 and 0.01. It's very funny. I don't know what you're referring to. That was funny. Now, Now, what we use is we use the symbol alpha. So this is the symbol alpha, the Greek letter A, to represent the what? Making a type 1 error. Does that make sense? And we use the Greek letter B, beta, to represent the probability of making a, what kind of error? Type 2 error. Good. And there's a problem.
Right.
Well, I'll tell you in a second. Okay, and what we usually do is we control the type 1 error, the probability of getting a type 1 error, between 1% and 10%. Okay, so we control that. Usually we have values that are 0.01, 0.05, and 0.10. Usually those are the standard values for alpha. But we still have a problem. You would like to basically make the probability that you convict innocent people tiny, don't you?
Less than 1%.
You would like to make it as small as you can. Practically zero, it would be great if you could. You don't really like to indict innocent people, do you? You don't want to send them to jail. Likewise, you don't want to, what? Acquit or set free a guilty person, would you? No, you want both those probabilities to both be very what? Low, very small. You don't want that to occur too often. The problem is, if you make one of these really small, the other one gets really big, and vice versa. So what you do, and as a statistician, what you do is there's a trade-off. Depending on what the problem is saying, you're either going to make, for this class, we're controlling this. But in general, if you control this, you make this really large.
It's like the confidence interval. Same thing.
Same idea, yeah. You lose precision. Right, you lose precision when you increase the confidence level. That's right. It's very similar. I know, and that's kind of along the lines that I'm thinking. So in other words, the smaller you make this, the larger you make this, and vice versa.
So the smaller you make
alpha,
you make
beta smaller. That's correct. And depending on what you're actually studying, is what you're going to pick these values to be. Okay? In other words, if you pick alpha to be a certain number, that's going to give you a value for beta. Now, how we get beta, I'm not going to tell you. Okay? That's a little hard, and I don't want to really talk about it in this class. Okay? In other classes, I would. I'm not saying in other Maths 227 classes. I'm talking about a continuation of this class, if that was possible.
Oh.
Okay? Yeah. Yes?
I'm sorry. You said the smaller you make alpha, the bigger beta's going to be?
That's correct. And vice versa. So since we're controlling alpha here, beta is going to be bigger, isn't it? It's going to be large. So we are going to get false negatives. But that's just what we're going to have to live with in this class. So we might acquit or set free guilty people. But if we didn't do this, if we didn't fix these numbers in our class, then we'd have to pick them ourselves, and I don't think we should really do that. Or we won't in this class. So what would you pick? It depends on the context of the problem. You might want false positives to be very low in probability. You might want what? False negatives to be very low in probability. So you have to, how you determine which is which is basically depends on the problem. It depends on what you're trying to look for, or try to avoid, maybe is a better way of saying this. Does that make sense? I mean, I can't go anything beyond that. I wish I could, but I don't have enough machinery for you guys to really understand it beyond that. I just don't have it.
And if you choose type 1, you would want to stay within that range?
You
want to be as close to 1% as possible.
Well, actually, yeah, what depends on the problem. I'm going to give you alpha in general. I'm going to give you this number in the problem. You don't have to really pick this at all. I'm going to give it to you. Okay? In other words, you don't have to find alpha. It's going to be given to you. Okay? It'll be in the problem. You'll just Go ahead.
Sorry.
Go ahead. No, it's okay. Go ahead.
And then from there, we have to choose if it's type 1 or type 2?
No. You don't have to choose. It's if you think it's alpha's, yeah, it's going to be given. I'm going to give you this number. I'm going to give you the number. You don't have to choose what kind of type error you have. This measures type 1 error. Beta measures type 2. So you're always going to be given a probability that you have a type 1 error. That's always what you're given in a problem, no matter what.
So we don't need to choose.
So you don't need to choose. You just have to look for it. Now, alpha the name for alpha is called the level of significance. Does that make sense? Okay?
What do they call it? Beta.
Not sure. Can't remember. Something, that's for sure. I used to know beta and alpha. Actually, even how to calculate them. I don't know how to do that. We never really say that in class. I'll look up beta. Next time I'll tell you in class. I'll tell you what it's called. Okay. All right. Okay, now what we're going to do, so now we're going to learn how to write conclusions. So what we did was we learned how to set up null and alternative hypotheses. We learned that the errors that we possibly could make. Okay? Does that make sense? These are the errors that we can make. Now we're going to learn how we write conclusions. That's important too. That's just very important. When we start 10.2, we're going to learn how we actually arrive at those conclusions. Does that make sense? So in 10.2, we're going to learn there's two different approaches to arrive at the conclusions, and we're going to learn that. Okay? On Wednesday, we'll learn more about 10.3 and how you write conclusion, how you actually figure out those conclusions on Wednesday after your test. Okay? So, if you reject what is that called, HO? The null hypothesis. Good. What do? Then you say there is sufficient evidence to support the statement in the alternative. And the alternative is our claim. So what you write is there is sufficient evidence to support the statement in the alternative hypothesis. That's when you reject the, what hypothesis? I thought I heard it. The null. Thank you. So when you reject the null hypothesis, you have evidence to support the alternative.
So you would say there is sufficient evidence to support the statement in the alternative.
Yeah, and whatever that statement would be.
Whatever that would be.
Yeah, whatever that would be.
That's the language you would want to say?
Yes, please. Yeah,
Okay.
please. Very good. Thank you, by the way. Now, if you don't, notice I didn't say you accept. Notice I didn't say the word accept the null hypothesis. Did I ever say that?
No.
No, neither do you want to say that.
Yeah.
You don't want to say that because you don't know. You might need to perform another experiment, and you might end up rejecting the null hypothesis. You just haven't performed the right experiment yet. Okay?
So it's just ruling out.
It's just ruling out, exactly. So you say what? If the null hypothesis is not rejected, or if we don't reject the null hypothesis, then we say there is not sufficient evidence. See the language?
Wow.
So in other words, that's why, now you see why I changed that H1 is true to H0 being false. Now you see. Because it's all related to the what? Null hypothesis. It really is. So either you reject the null hypothesis and you say there is evidence to support the claim, blah, 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 blah. Or you you do not reject the null hypothesis, or fail to reject the null hypothesis. That's another way to say it. You could fail to reject it. You could say that. And then you'd say what? There is not sufficient evidence to support the statement, blah, 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 blah.
The alternative.
That's right. Does that make sense? So you never say accept the null. Never. Ever. Ever.
Ever, ever?
Ever, ever, ever. Forever. Exactly. Gotta do that on Sundays. That's really important. Okay, so you see the difference between the two? Any questions on this? You're quiet. You got it? Okay. Can I go to the next slide? Yeah? Guys are okay? Everybody okay? Everyone? Everybody's saying anything.
Well, you're gonna give an example between the two, right?
Yeah, in a second, absolutely. Does this make sense? Okay. So let's do an example. So, in 2007, the mean, what is that, SAT score on the reasoning test for all students was what? 710. That's your hypothesized value. That's the value of the null hypothesis.
Got it.
And the alternative as well. Okay? A teacher believes that what? Due to heavy use of multiple choice test questions, the mean SAT reasoning test has what? Decreased. So is that going to be a left-tailed, right-tailed, or two-tailed? Left. Because it's what? Less than.
Now,
Yeah.
the null is 710.
It says the mean. Go ahead.
And the alternative is the mean? No.
No, well, this is the mean. What are you testing? See, remember, the parameter you're testing with the null or alternative hypothesis is always either the mean, mu and mu, or the population proportion, P and P. They can't be different. This parameter has to be here,
Okay.
or on the alternative. They have to match. You can't have two different things. You have to write this. If you write just the number, it's wrong, because you're not telling me what the parameter is.
All right.
And that's really important. Does everybody understand that? You have to write the parameter. You know what I mean by parameter? Parameter is either the population mean or the population proportion. P or mu. You have to write that. Otherwise it's flat out wrong. Yeah.
So it's less than.
Yes, they have to be the same.
There you go.
They're the same, but notice what it says here. Well, I mean, they have the value, they have to be the same, but what this says is that the mean is equal to 710. This says the population mean is less than 710. So technically, even though they have the values have to be the same on the end, they're really not the same, are they?
Is this the left hand?
Yes.
Okay, so we did the left hand.
If you want to, you could. Yeah. Just know that, even would be better.
Yeah, no.
So any questions on that?
And then as far as the wording, we want to look at it.
Exactly like that. Now, let's explain what it would mean to make a type 1 error. So remember what a type 1 error is. You reject the null hypothesis when it's true. When it's true, right? When it's true.
Right.
So that would mean we would reject the null hypothesis that says that the mean or the average score on the SAT reasoning part is 710, when in fact it really is 710. Does that make sense? So in other words, the error that we would make when we make a type 1 error is when the sample evidence leads the teacher to believe that this is actually not true, when in fact it is. You see what I'm saying? You reject the null hypothesis when it's actually true. So, go ahead.
How come you said it was false
So,
for the type 1 now?
I said you reject the null hypothesis. No, I said that's for type 2 error. I said with the type 1 error, you reject the null hypothesis when in fact it's true. Type 2 errors is you do not reject the null hypothesis when in fact it's false. They're different.
So the first one is true and the second is false.
No.
What? No, you gotta be careful with how you say that. No one.
Type 1, you reject it, and type 2, you do not reject it.
Okay, I see. I see what, I wasn't looking at that.
Yeah, context, really, there's two things here. Here, you're saying, well, we think it's false, but in actuality, it's what? True. The other one, we think it's true, but it's actuality false, right? Does that make sense?
No.
That's okay. You're okay when you reject the null hypothesis. Okay, the type 1 error says you're rejecting the claim that you're rejecting the null hypothesis, which says that this parameter mu is equal to 710. You're rejecting that, but in actuality, it's actually what? It's actually that is true. It's true. So you're making an error. You reject this, but in actuality, this is what happened. It actually is that value. That's what we call a type 1 error. So you acquit. Oh, excuse me.
No.
You convict an innocent man or woman. That's what you're doing here. Does that make sense? When you commit a type 1 error, you're convicting innocent men and women. You know what I mean by convict? You find them what? Guilty. When in actuality they're innocent.
Right.
They didn't commit the crime. That's a type 1 error. A type 2 error would be you would set free a guilty person.
Right. Okay.
Okay? Does that make a little more sense?
Yes.
You missed the part about that, I think. So I went through the parameters and all the terminology, but it's going to be recorded.
Is this right here?
Oh, nice.
Yeah. It's very crude, though. Very, very, very crude. I warn you. It's very crude recording. Yes. Yeah. Yeah, I'll flash by. Yeah, I will. The force is strong with everybody. Okay, now let's explain type 2 error. So this is what? When you set free a guilty person? So in this case, what does that mean?
Not rejecting?
Well, we actually don't, that's right, we don't reject the null hypothesis. In other words, when the sample evidence leads the teacher to believe that this is true, when in fact it's actually smaller than 710. Right?
Yeah. Less than something.
Mm-hmm. That's smaller.
Yeah.
Okay? So B and C are errors. B and C is what you want to try to avoid as much as possible, right? I mean, we can't completely avoid, we learn we can't completely avoid them, can we? Remember? Why? Because if we make one bigger, the other one gets smaller. Excuse me, if one's smaller, the other one gets bigger,
Right.
and vice versa. We can't, so in other words, we can't win.
That's right.
Now, that's what B and C are. Those are the can't win scenarios. D is what we want to say. So let's say, how would we write the conclusion if we actually rejected the null hypothesis? Well, we write it as there is enough evidence to support the teacher's claim the mean stat reasoning test score has what? Decreased. Does that make sense?
That's what you hear on TV all the
Mm-hmm.
time.
Yeah, we do. This language, it really pops up.
You hear it all the time in your doctor's reports too.
That's a good point. Thank you. Thank you. That was actually really good. Thanks. I must go to my doctor's reports more often.
My doctor, it's really nice. You email each other, sends you the report, tells you what they actually mean,
That's nice.
all the different parameters that go with it. Yeah, it's
That's pretty
nice.
cool. Very thorough.
Yeah.
Would you guys want to keep going? You want to keep going, or do you need a break? Anybody need a break? Okay, let's stop it. And because I don't want to waste battery life, I don't know how to do this. Let me just do that.
But we need to kind of absorb what you're saying because it's contradicts each other somewhere or other.
In what way?
It really doesn't.
In what way? Hold on.